Hello, for this section we're going to deal with how to graph and analyze quadratic functions. So first of all, what a quadratic function is by definition, we have f of x equals ax squared plus bx plus c. And if you recall, we did this, or we looked at this in chapter 1 as far as how to solve it when we did either factoring, completing the square, or quadratic formula. But this one is specifically designed for more of the graphing purposes, whereas in chapter 1 we just looked at how to solve them. Okay, so the first thing is, why is this a quadratic? It's a quadratic because your exponent is a 2, or the highest exponent, or the degree, is squared. So that is known as a quadratic. The other thing is that I almost forgot this, a cannot equal 0. If a equals 0, then it's not a quadratic, then it goes back to a line. So for this particular thing, that's what makes it a quadratic, is when you see that squared, or as the highest exponent. Now that that equation can be rewritten. Now the book here calls it standard form. I refer to it as vertex form. So I'm going to put that like that. And all these quadratics can be rewritten, and it's kind of easier to graph it when it's in this type of scenario: x minus h, the quantity squared, plus k, where h and k is the vertex. Now what the vertex is it's the high or the low point, depending on if it goes up or down. It's that turning point in the parabola. You know, a parabola looks like a U-shaped, much like the arch in St. Louis is a perfect example of a parabola. If you have a McDonald's, you have two arches connected. Those are both parabolas if you separate them. But the vertex is the high or the low point. And in this particular case, it's nice to have that. Another thing that we also refer to, because all these parabolas will either open up or down, would be an axis of symmetry. Now what an axis of symmetry does is it cuts the thing in half, the parabola in half, and allows you to get points faster. If you know one on the right side, then the left side should mirror it. So an axis of symmetry would also be helpful. One other thing about the A, if the A is greater than 0, which means positive, it's going to open up, and if A is less than 0 or negative, then it will open down. Okay? And if you recall in chapter 2, where we dealt with the transformations, you'd have that negative on the outside, that would flip it over the x-axis. Okay, so that's kind of what that's mirroring. This form is very similar to what we did in chapter 2 when we dealt with the transformations, as far as shifting and vertical stretching and reflection. So let's walk you through on how to get it into that form. So the first thing that we do, given an equation, is we're going to rewrite this in that standard form, or vertex form. Now, if you recall what we did way back in chapter 1, we did completing the square. And at that time, I think I said, I use only completing the square for rewriting equations. I don't usually use it to solve them. Here's the part where I use completing the square in order to solve this, or to get it in that form. So the first thing that I'm going to do is I'm going to take the x's and I'm going to push them off by themselves, and the constant I'm going to just move over. So all I'm doing is just rewriting it. Notice they're on the same side. Nothing's changed. I just made some room. Now the next thing that I want to pull out of the x's, just on these two things here, is what they share in common. I can divide a 2 out. And I say that, and I should have said this a little bit better, but what I'm pulling out is the number, not the x. Okay, I don't want to pull the x out because I want it to be a quadratic still on the inside. Now what's going to happen is that I am going to complete the square. And again, in order to complete the square, your a had to be 1, and it is on the inside, not in the whole thing, but on the inside it's a 1. And then you take b over 2, the quantity squared. In this case, we have negative 6 over 2 squared. Negative 6 divided by 2 is 3. 3 squared is 9. So I'm going to add a 9 in here, And then to balance it out, if I add something to one side, I also have to subtract it immediately, just so that way it's there, it did its purpose, but it's not really adjusting the formula at all. The difference is that this isn't really a 9 that I put in there, because if I refoiled this out, that would actually be an 18. So I'm subtracting an 18 on the outside just to make it balance. If you don't do this step, you are going to be off. That is an important part of it that you need to have, just so that way it makes everything balanced. Now from here, I'm going to factor, and again, this just follows the rules of completing the square. And then I cleaned up the outside. 13 minus 18 is negative 5, and now I have it in that form. Now when I go to find the vertex and sketch the graph and whatnot like that, when I pull these out of here, this number, for instance, would be a positive 3, and this number here would be a negative 5. If it's on the outside, it is as it is. If it's in the inside, it goes the opposite. It's very similar to when we did the shifting. If it's on the inside, when it's a minus, you would go to the right 3, and if it's on the outside, you go down 5. So in order to graph this, what I do then, I'll make it go up here a little bit like that, is I go over 1, 2, 3, and then down 1, 2, 3, 4, 5, and make my dot. Now that is my vertex. Now according to this number here, the one that I just circled, the 2, that means it's going to go up, okay, because that number is positive. Now, as far as finding some of the other things that are involved in this problem, and I'll use a different color here, the 13, the constant, is the y-intercept. So if I go up 1, 2, 3, 4, 5, 6, 13, let's say that that's 13, that is the y-intercept. Any constant is going to be your y-intercept. And in order to get that, if you didn't trust that, would be if you put 0 in for x, you should get 13 out. Now, with that axis of symmetry that I was mentioning, that your book does not, it's like this imaginary line that goes right down the middle that cuts it in half. If that's 3 spaces this way, then I can go 3 spaces this way and have another dot. Now, in order to make a parabola, you need 3 dots for sure that are not in a straight line. And once you have 3 dots that are not in a straight line, you can connect any parabola that's possible. So for this particular case, that's all I need. Now in your book, they might also ask you for the vertex, which we labeled, the y-intercept, which we have, and then also any x-intercepts. Now for x-intercepts, for something like this, you actually have to, or you would have to then solve for x, either using the quadratic formula or completing the square, since you already did that kind of, or factoring if it could. So that's something that if you want to revisit what we did in chapter 1, section 4, that's where that would be located at. And then as far as sketching the graph, we did that domain and range. The domain for these is going to be all real numbers. There's nothing that's going to affect it. We're not dividing by a negative, and we're not square rooting, so therefore the domain is okay. And the range is going to be when you go ceiling to, or floor to ceiling, it's going to be a bracket this time, because it is going to equal negative 5 as the low point, and it's going to go up to infinity forever. So as far as the actual graph goes, we found all of the stuff. We put it in the quadratic formula using completing the square. Now, if you're interested in doing another thing, then another way of finding the minimum or maximum value, if they ever ask you for the minimum or maximum value, they're actually just asking you for the y-intercept or y-coordinate of the vertex. Now, there is an equation for minimum and maximum that you could actually use in order to find your vertex if you want. If you use this formula, negative b over 2a, that will give you the x-coordinate of the vertex. It will also give you the x-coordinate where the minimum or maximum is at. Then what you do is you insert that number back into your equation, and then you find the y-coordinate of the vertex. So to give you a formula, or to give you an equation, I'm going to come up with the same type of answer using this formula rather than using completing the square. Because I know that completing the square, if you don't do it a lot, it's kind of tedious. You lose steps and you forget, and you know, it gets kind of complicated. So on this particular one, negative 30 is in the B's position, divided by 2 times 5. Now on the top, two negatives make it a positive, so it's positive 30. And on the bottom, 2 times 5 is 10, and 30 divided by 10 is 3. That's the x-coordinate of this vertex. Now in order to find the y-coordinate, we're going to insert the number 3. And why the number 3? Because it's the number that we got when we did this equation, or this little formula. So be very careful when you're doing this. The order of operations do come into play. So the exponents go first and then multiply. Do not take 5 times 3 first. You do 3 squared, which is 9, and then 9 times 5 is 45. On this part, negative 30 times 3 would be negative 90 plus 49. And then when you add left to right, negative 45 minus 90 would be negative 45 plus 49 is 4. So what I just did there was I actually found the vertex. The vertex for this particular problem is 3, 4. Now, how does that help us? Well, that's the higher the low point depending on if it opens up or down. Since this opens up, and the reason why I know it opens up is because the A was positive, then I know that that's the low point or the minimum value. Okay, now if I use that to graph it, how I could do that is I could make a dot at 1, 2, 3, and then 1, 2, 3, 4. There's my vertex. And then using the constant, the 49 that I just circled, I would go up 49 spaces, which it's going to be way off the page. So let's just pretend it's way up here. And then since it went 3 to the left, that means 3 to the right. And I have another dot, and then I make my parabola connected. Now, of course, you can label your axes however you want. You know, if you go up by 1s, you'd be making 49 different tick marks. If you went up by 5, it might be a little bit better. As far as that, if you just change your scale, that's not a big deal. Just make sure if you do change your scale to let the reader know what you changed it to. You know, if I leave them as a, if I don't mark them, then the reader understands it to be a 1 rather than a 5 or a 10 or whatever that you want it to be. So with that particular thing, what I did is I created the graph, I created the vertex. I just didn't put it in that vertex form. If it ever asks you for that, then here's how I do that. Remember, the vertex form is a x minus h, the quantity squared, plus k. Well, I found h and k. The only thing I didn't find was a. But a is right here. It's in that form of a quadratic function to begin with. So my a is 5 in this case. And then x minus 3, because that was the h, squared, plus the 4. And now I've got it in quadratic formula, or standard form, or vertex form, whatever you want to call it. And I didn't have to do the completing the square in order to get that. Now, some people like completing the square, some people don't. Me personally, it's up to you. Whatever you want to do in order to figure out the problem, that's fine with me. So for whatever they've asked me to do, finding the minimum and maximum, finding the vertex form or standard form of the equation, graphing it. The only thing I probably didn't do was find the domain and range, which the domain would be all real numbers. The range would be from 4 to infinity because it goes up. Now let me do one that goes down. If I can find one here. H of x equals 3 minus 4x minus 4x squared. Now, just to kind of remind you a little bit, the number or the letter in the front, the H, this time I've been using F, and that's kind of the standard, but when it has a different one, that doesn't mean anything different. That just means a new function or a new machine. Okay, that's the only thing that does. is it just makes it known that, hey, this is a different one. This is your, like on the G machine, this is your iPhone. On the H machine, that's your iPad or something like that. It's just a different machine, but they do some of the same stuff. Okay, so I'm going to do this the new way, where I'm going to use that x minus or equals negative b over 2a, just to show you again how that works. So the number that's in the b position is the negative 4. It's the number that is in front of the x term. And then the a, remember, is the number in front of the x squared term. So be very careful that the signs need to go with your pieces. If the signs don't go in there, then you're going to get a sign wrong, and then it's going to be off. The 3, remember, is the c. That's the constant, or where it crosses the y-axis. So if I clean this up a little bit, 2 negatives make it a positive 4. On the bottom, 2 times negative 4 is negative 8. And when I reduce that down, I get negative 1/2. Now when I insert that into my equation, 3, negative 4 times negative 1/2, minus 4 times negative 1/2 squared. So I know my students a lot of times use decimals. If you use fractions, it's not really going to make a difference. It's all personal preference as far as this goes. Some of the things with decimals, though, if it does come out to be something that never, that doesn't stop and whatnot, it's going to be kind of messy. And if you round, it's not necessarily the exact answer. So I usually leave mine in fraction form. However, it just depends on your instructor what they prefer. But negative 4 times negative 1/2 would be a positive, and then 4 times 1/2 is 2. Again, for this, we need to do the exponents first. So I would have negative 4 times 1/4. And again, how I got 1/4 is I took negative 1/2 times negative 1/2. 2 negatives make it a positive. And 1/2 times 1/2 is a 1/4. And then when I multiply that together, I get negative, I get negative 1. Now adding all those together, 3 plus 2 is 5, minus 1 is 4, and I end up with a vertex of negative 1/2, positive 4. Oh, I don't need that parenthesis there. That looks goofy. There we go. So as far as coming up with my graph, I make my axes and I go back 1/2. Now for me, I'm going to go back by ones, so I need to make this halfway, or about, or appear to be halfway between there. And then the y-intercept is 3, which means it crosses right here. Now if that's 1/2, and that's 1/2 a space over to the right, then 1/2 a space over to the left, and I have my dots, and I end up with a parabola that looks something similar to this. Okay. Now again, most of you will probably just graph it using your graphing calculator, but this is me actually using the picture in order to, or the graph in order to make the picture. I'm not using my graphing calculator right now to do any of this. So as far as rewriting it into vertex form or standard form, the a in this case was negative 4. Again, we located that up here. X minus, but then when I put in a negative 1/2, 2 negatives right there will turn that into a positive, and then plus 4. And now I've came up with the vertex form of the parabola. I sketched the graph. If it asks you for the minimum or maximum value, this would be a maximum at 4 when x is negative 1/2. Me personally, I just kind of like it when people just label the vertex on there. If they ask you for domain and range, domain, remember, for this is negative infinity to positive infinity. And the range this time is negative infinity up to 4, okay, because it goes down. So that's the difference with that one. If they ask you, let's see, for the x and y intercepts, the y intercepts was 3, The x-intercept, we'd have to do a little bit more work. We'd have to, use the quadratic formula or completing the square in order to get that. It might be a little bit more involved, or a little bit would definitely need another slide, but that's something that if you revisit section 4 of chapter 1, that would talk you through how to solve those. Now the only difference is if they ever just ask you for the minimum or maximum value of the function, that's just finding the vertex and using what we did there. Cut out the graph and you just found the minimum and maximum value of the function. So as far as section 1 goes, that's it. So thank you.